here's our graph of voltage versus time. As you can see, it's very apparent here. The voltage spikes up and then stabilizes for the rest of the time. It goes up slowly, but it goes up very small as time goes on, because as you fill up a battery, it's harder and harder to push more charge onto it. So this is apparent with our current versus time graph. So as the general trend here is, as time increases, the current decreases. We have a few spikes, and that error is due to the chemicals in the battery. We don't really know what's happening in there. Something could build up in there, and that could cause our current to spike. We're not really sure. And okay.
My bad. Here.
So as you can see, as you charge up a battery, the current goes down. The current that is produced goes down because it's harder and harder to put charge onto there. It's harder to push it on, so the current goes down.
Mm-hmm. All right, so now we're gonna talk a little bit about like the application of all of this. We learned a lot about solar panels, but how does it, apply to our lives? And even from a business standpoint, how can people, I guess, profit from this? So first, let's look at a Tesla. Basically, just bouncing off what Malav said before, it takes more and more time for the same amount of current to, I guess, get filled up in an electric, I guess, battery, right? So here in 30 minutes we get 100 miles, but then it takes an hour to get the same 100 miles of mileage, and then 4. And basically what he said before is, as you have more charge in that battery, it is harder to push in even more charge in it, because they're just going to be pushing off each other. And all right, now we're going to actually look at our own Old Bridge High School and see how their solar panel investment is going to work out for them. So we don't know the exact measurements, but we know generally that they have solar panels installed in this area right here, and we measured it through Google Maps to be around 875 meters squared. And then we looked up the average area of a commercial solar panel, which is 2 meters squared, and then we just estimated that we should have around 438 solar panels installed here. And then that actually creates 3.6 times 10 to the 6 joules per 1 kilowatt hour, which is totally insane. This I'll actually show. I want later how it applies to even the house. So this is like the typical consumption of our energy in pink throughout the day. It will actually spike a little bit up in the morning and then at nights, and this could hold true for Old Bridge High School too. But the main thing to get away from this is that the solar panel energy output will obviously just be a nice parabola as the sun goes up and down. And here in purple is the area that the solar panel actually covers energy-wise, and this is estimated to be around 25% across the board. So you might think, all right, well, what about the other 75%? What happens to all this energy, right? Well, actually, there's a system in place where you actually send it back to the electric grid, and the state will actually pay you for the energy that you provide when you don't use it. And there's an actual, the actual rate is 15.28 cents per kilowatt hour that you get. And then I want to show you actually how the payoff works with this. Because okay, so first, average solar system, that's 6 kilowatts, which is on average, that would be $11,802. And then for energy costs, electricity costs around 15.28 cents per kilowatt hour. So this is the amount you'll be saving for every kilowatt hour you produce with your solar panel, right? So what we do actually is we just add those up, because that's what you'll be saving, right? And then we just multiply it by the 6 kilowatt hours, because that's our solar system. And then you multiply that by 365, because total days in a year to find the return on investment for the year. And then what I did was just divide the cost of the solar system by that number, and I got 12 years. In 12 years, you'll be able to pay back your solar panel. And this is actually a overestimate because the average I saw was 4 years for New Jersey, and the reason why is maybe because they took into account the other benefits of having solar panels, such as an increase in real estate value and also um, no effect on the property taxes. So that definitely plays an important role, and that will definitely benefit you even more. So, all right, now we're actually going to look at the pros and cons of a solar system. So, uh, as Malav shown, like the power output of the sun is immensely high. So, if we are able to, I guess, increase the efficiency of our solar panels, then it will be a very great payoff. But for now, it's just there's too many funding complications. It still costs like a lot to set those up, and although the return on investment does come up eventually, another problem that might arise, that does arise actually, is that not all areas can use it the same way because obviously the sun doesn't uh, you know doesn't affect all areas of the planet the same. But also on the flip side, it does help. It's a viable solution for underserved areas with a lot of sunlight, and it actually is extremely durable. It would last for 10, 20 years without like many defects, because if you think about it, the only thing moving through there is actually the energy itself. No other parts of it has to be, I guess, touched. And as I said before, um, they have they increase real estate value by up to like 5%. I saw, and then um, another interesting thing I found was that the resale value diminishes with higher power output. So people, as long as you're like if you're selling houses, as long as your house has the solar panels, it gets that like initial boost in value, but it doesn't matter if you have more. So people just care that it's a solar panel home, not how much power it actually generates, which could kind of be seen as a drawback. So our unbiased conclusion is that solar panels are definitely the future, but there just has to be more work done for them to be efficient enough for us to like, I guess, accept it commercially. Like, because one thing that we saw is that selling your energy back to the state, it is a little bit less profitable than actually using it yourself. So one thing that is really uh, under, I guess, invested in is batteries, like solar panel batteries. And the reason why is because they're very expensive right now. So like as soon as that uh, the 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 cost of that goes down, solar panels should be used by like everyone really. And yeah, and this works. We're excited. So that's the end of our presentation. You good, Malav?
Yep. Thank you, everyone.
Yep. All right. And now we'll just stop the video.